Welcome everyone. So today we're going to be analyzing the thousands of broken Kubernetes hulls out there and the lessons from the wreckage. So unfortunately, we're not going to be talking about the Titanic or, the Ever Given that got stuck in the Suez Canal. Nothing like that. Just looking at Kubernetes today. So I am Tyler. So I've been working with Rancher Support, and what we're doing here is we're going to be going over some of the results we've gotten from one of the tools we've developed, just to be able to help customers kind of go through and make sure their systems are running kind of at peak performance and maximum supportability.
Yeah. Hi, and I'm Tony Hansen. I've been also working with the Rancher Support team for about 3 years now, and yeah, this is a really neat tool that I like talking about. So,
all right. So the agenda today. So first of all, we're going to be going over what is this tool. So what is the Supportability Review tool? We're going over how it works, what are the things it's checking, and we're going to go over what a report looks like at the end of it, right? So next up, we're going to be going over some of the common issues that we've seen, right? So over all the clusters that we have been able to scan from the customer environments, like real environments that are out there, what are the common things that we see that people are missing? And then finally, we're going to be looking at the future of this tool. So what's coming up, the enhancements, and everything that's kind of coming from that.
all right, so what is the Supportability Review tool? We will probably call it the SR tool at least once or twice throughout this presentation, just because that's how we usually refer to it in shorthand. But what the Supportability Review tool is it's a tool to check how supportable your clusters are. So to start with, the way it works is it uses Sonobuoy and Kubebench, very similar to the way our CSI benchmarking tool works, if any of you have used that. It uses Rancher's connection to the downstream clusters to connect to every node downstream in every downstream cluster and pull metrics. And the metrics are then all compiled in a tarball by Sonobuoy, which then you send off to the support team, and we end up reviewing it and compiling a nice looking report for you. What's really nice about the way it works is that we are only pulling the specific metrics we're interested in, so things like node pressure, network latency, how many pods are running, things like that. We're not pulling any specifics such as, oh, here they have this number of secrets, here's what the secrets contain. We're not collecting any of that information, we're just collecting the basics.
So next up, we'll go over kind of the categories that we have here. So at this point in time, we have about 60 checks that we do per cluster and about another 35 additional checks for Rancher itself, right? So these checks span 4 different categories that we have listed here. So first off, operational best practices. So these are things that Kubernetes says is the right way to do things, right? So we need to go through and make sure that you're following what Kubernetes itself says is the best practice. Next up, we have some checks that are looking at security, right? So just checking at the base level, kind of what are some CVEs that we have found in Rancher, and we want to make sure that you have actually fixed those issues in your environments if you're self-hosted. Next up, we have support matrix conformance. So this is going over and just making sure that the environment you're running, right, the Kubernetes versions, the Rancher versions, the application versions, everything there actually meshes up with what we have in the support matrix. And then finally, we have design validation. So this is looking at how you've architected the system, both your upstream clusters and your downstream clusters as well. Just, again, to make sure you're following some best practices when it comes to design.
Awesome. So next up, we're going to take a look at an example report. We spun up a lab environment, ran the collector on it, and then generated a report specifically for Suzicon. And we're going to look at that live. As you can tell, it's big.
Very well.
All right, so the first thing that you'll notice whenever you get a report is that you have this lovely little cover page. It says what the customer name is, when you collected the data, when the report was first generated, and all of that. And then we go down into the table of contents. But the first thing in the table of contents is the executive summary. The executive summary is going to give a really high-level overview of everything we found as we reviewed the cluster. It's very much written for those people who don't want to read a 30-page report going into every single check and every single finding. They just want high-level, here's what we need to fix across all our clusters. Here's the really high, dangerous things that need to be fixed immediately, any of their focus points, any of that. And the executive summary is really nice because it is handwritten by whatever support engineer is reviewing your bundle that you collect. So we don't just generate an executive summary, we actually go through, look at all the checks, and then summarize it for you by hand.
Yeah, so just to add on to this a little bit, right? So as you can see here, this is a lab environment that I spun up. You know, we have a k3s cluster, RKE, RKE2, and an EKS, right? So we have checks for all of these clusters, all the other cloud providers as well, Harvester, right? And they all have a slightly different set of checks in there, right? So you might think that cloud clusters, obviously we don't have access to that control plane, so we can't check anything there. Whereas in the things like K3s, RKE, RKE2, we can tailor some more checks in there just to make sure, again, for architecture and for best practices, just to make sure you're following those things. So following that up, this is kind of a good example of what we would go through. We might list things that are end of maintenance, end of life, different checks that you might have missed as we go through there. Right, so quite a big list of things we go through. We have a disclaimer in there that just goes, obviously, we aren't going to go through and fix it just because we found in this report, but it is something that we go and work with you on, right? So we find these things and we can go through and actually help you actually implement any fix that you need for this.
All right, and then so now we get to the first cluster. Each cluster is going to have a very similar looking session to this. You get the title page, you get how many nodes it is, what version of Kubernetes it's running, just really quick. And then you get this nice little review panel. It tells you how many checks there were for this cluster, passes, warnings, failures, and then skips. The nice thing with the skip checks is we intentionally don't do checks that we know you're going to fail. For instance, we have a check for if Rancher Backup is installed. If Rancher Backup's not installed, you don't also need to know that, oh, you need to have Rancher Backup taking regular backups. You need to have Rancher Backups being stored offsite and all the other related things to Rancher Backup because you're already missing step one of that, which is just getting it installed. So we do intentionally skip some checks, and then they're broken down here into the 4 sections, just so you can see overall operational best practice. This cluster is doing pretty well, but we probably need to look at its architecture, look at the design validation for it.
Yep. So following that up, we get a more in-depth list of all of the warnings and the failures that you kind of see in these clusters. So obviously in this case, this is a lab environment. It's just a 1-node cluster. So you see a lot of things in here that are talking about, hey, well, why don't you have a minimum of at least 2 nodes in the cluster? Why don't you have, at least an odd number of etcd nodes, right? Things like that, that you'd see perhaps in a lab environment. But there are other checks in there that might fail as well, right? Like we have down here, no reoccurring Rancher backups. So if this was an actual live production environment, this would be something that you'd want to actually go in and rectify.
And then, yeah, since these are lab environments, unfortunately, they're all single node clusters. But something that's really nice about this is that if the check only fails on specific nodes in the cluster, we'll provide a list of those nodes here instead of just saying, oh, you failed this check. Good luck finding out where it's, oh, you failed this check. Specifically, these 3 nodes are failing because /var is close to hitting disk pressure. Please go look at those nodes. You don't need to hunt and guess which nodes are causing the issue.
So skipping a bit down here just to the sections after going through all these clusters here. So we do have an actual system summary report in here. So again, if this report is presented to maybe a higher up in the company, a manager, someone that isn't deep in the weeds, they might not need to see each individual check for each individual cluster. But they might find it actually useful to have an overview of all the clusters, you know, what versions they're running, and same thing for the nodes down here, right? So what OS are those nodes running? What version of containerd or Docker are they running? So things like this, again, you can get a nice overview, especially paired with what you see above, right? So when you get those checks saying, oh, there's a mismatch between versions, right? Perhaps we only support a certain version of Docker given a certain version of Rancher and Kubernetes, right? So you can actually go through, and it gets pretty easy to go through and find where that actually is.
Yeah, if any of you have ever run our system summary report before patching or anything like that, it's the same output up there that our system summary report used to do separately, and we've just included as part of this tool, because again, it is helpful to know how many nodes you have, where they're located across clusters, all of that information. Yeah. And then this is a really nice bit that I liked, is at the very end of each report, we include this list of EOM and EOL versions. So if you have anything that it has gone EOM or EOL, we will highlight it here. So for instance, we can see that we're running K3s on Kubernetes 127. Well, Kubernetes 127 went end of life back in June of last year. So we provide that list so that you can be aware and start working on your patching schedules to try to get back up to date. And then the very final thing is if you want to see all the checks, not just the failures, it's listed here in an appendix. And it's broken down by cluster type. As you can see, there's a lot of different checks. Some of them are the same between clusters, some of them are cluster specific. But it will give you all the checks that are at all possible to run against those clusters, whether we skipped them, whether you passed, whether you failed, whatever.
Yeah. So again, we aren't going to go through each individual one there, but what this report really does give us is a very nice overview and a very nice way to actually go in and have that conversation, right? So, and talk through all of these things. So there's definitely a few really good audiences for when you do get these reports, right? So if you're new to Kubernetes in general, this is a very good way to go through and catch those things you miss just because you don't know, right? For example, when we get into the common mistakes we see, there's some in there that you really don't know unless you've read some of the docs, right? So we'll go through those next.
Yeah. All right, yeah, so now we're going to cover the 7 most common issues that we have seen, broken down by all the different supportability reviews that we have done. So the very first one is swap. For some reason, we still see that almost 14% of clusters have an issue with swap, despite the fact that Kubernetes recommends that swap is turned off on all nodes. That's an operational best practice. The main reason why Kubernetes recommends that we turn off swap is because it is just slower than adding more RAM. This causes issues. For instance, if your database really needs a lot of memory and all of a sudden part of it starts swapping instead of using real memory, you start seeing latency on your web apps. Luckily, this is easy to fix. You just turn off swap, remove the swap devices from FS tab. You don't have to worry about swap anymore.
Now, for those of you that are observant, you might actually know that in the most recent versions of Kubernetes, they do actually have swap as a beta feature that you can enable it and can use it with Kubernetes. But again, that's a beta feature. That's something that's very bleeding edge for Kubernetes and is intended for very specific use cases.
Yeah, the docs on swap for Kubernetes, even in beta, it's only for these specific types of workloads, and make certain you use the right QoS to make certain you're not accidentally swapping on something that you shouldn't be. So it's very interesting.
All right, so next up, DNS cannot hit an external name server. So again, kind of a weird thing that you would see in a lot of clusters, but almost 15% of the clusters we've scanned have had this issue. So this is where one of the name servers that you actually have in your resolve.conf is unreachable for one reason or another. So this can obviously cause problems, especially depending on how you have core DNS set up within your Kubernetes cluster to actually go through and check those name servers, right? So if you have round robin, if you have, going through the list in sequential order, right? Depending on how those name servers are listed in resolve.conf, this could cause very frequent issues, right? Another thing to consider is this might actually only affect a certain subset of your nodes, right? So if you have a different resolve.conf on, one set of nodes versus another, you might not actually see this problem across all pods in your clusters. Or perhaps a workload is bounced across 10 nodes and only one of them has this problem, right? That could become a very infrequent but difficult to troubleshoot thing. This is a good thing to go in and look for. Can cause problems with image pulls, cause problems with talking with other applications and things like that. So again, a weird issue, but definitely something that is easily fixed once found.
But really hard to troubleshoot why does this pod only fail on node 7 every time?
Exactly.
The next big issue that we see is too many CRDs. We have an operational best practice where we recommend less than 100 CRDs for every downstream cluster. But we see almost a third of the clusters that we've scanned have more than 100 CRDs in downstream clusters. And out of all of the clusters we've scanned, we've also seen where 13% of them have deprecated CRDs. An easy way to avoid deprecated CRDs is to make certain you're keeping up on what CRDs you actually have installed in Kubernetes to make certain you're not having too many. Additionally, having too many CRDs downstream will slow down Rancher, it will slow down your Kubernetes cluster because every time you make a kubectl command, it compiles a list of all available API endpoints, which means it has to check that every single CRD installed in that cluster is reachable. So once you start getting over 100, you start actually seeing real slowdowns as you try to do things with Kubernetes. There was another company, and their name is escaping me right now, who's actually done research into this. They have literally stress tested the Kubernetes API server in kubectl to find where the breaking point is and what kernel parameters and Kubernetes parameters need to be tuned if you want to use more than 100 CRDs. And again, this one's relatively easy once you know it's an issue. You go through and you make certain that you've removed any CRDs that are no longer in use. But again, hard to catch if you're not looking for it.
All right, so next up, this is one you expect to see in a dev environment, but even in all the production clusters that we've scanned, we still see lots of cases where there are pods not running, right? It's a very simple thing. You'd expect to be able to catch some of this, but if you have gigantic clusters, you're missing that observability, that monitoring, you might not catch things like this, especially if it's not a core workload of yours that's having an issue. Maybe it's a core Kubernetes component instead that's having these problems, right? So if you don't have eyes on that sort of stuff, you can run into a lot of problems here. Now, this could also be affecting jobs, right? So cron jobs are just regular jobs within your Kubernetes cluster. So if you think you've gone through and actually upgraded some things using a cron job or a regular job, and that's failed without you knowing, the cluster might actually be in a different state than what you expect, right? So imagine you've gone through, you tried updating your application, it actually failed to do so, and you don't notice, right? You might be expecting different results, different outputs than what you're actually getting, and this can definitely cause a lot of problems. So as always, it's good to have that observability, those eyes on the pods, right? The actual workloads in there, just to make sure that they are all running.
All right, the next biggest issue we have seen on a third of all clusters, though when we break it down to just our K2 and K3s clusters, it's almost 50%, is that they have certificates set to expire within the next 90 days. For those of you who haven't run into this issue, our KE and K3S are both set up to automatically rotate certificates if you restart the service within 90 days of the certificate expiring. However, if you don't do that and your certificates expire, you can see all your Kubernetes components start to fail, etcd stops being able to communicate within the etcd cluster, you start just having all sorts of problems. Again, easy fix, just make certain you reboot the boxes regularly or restart the services regularly. But we saw this on almost 50% of clusters that when they ran the supportability review, they were unaware that they were about to have all their certificates expire.
Yep. And again, this could just be a great reminder if this is something you're aware of, or if you're very new to Kubernetes, you know, this is your first time running RKE2 or K3S, you might have been unaware that you need to go ahead and rotate those certificates yearly. So this is a great way to catch those sort of things and make sure that you actually do that. So next up here, authorized cluster endpoint. So from here on out, I'll call it ACE. So about 44% of the clusters that we saw were actually missing ACE. If you don't know what this is a great way for you to, once implemented, your kube configs that you pull in through the Rancher UI will allow you to actually route directly to the downstream cluster instead of routing through the Rancher WebSocket connection to the downstream clusters. So, few scenarios where this is actually really, really useful. One is if Rancher's gone down for one reason or another. Perhaps the upstream cluster is having issues, you've lost a node, Rancher's down, maybe an upgrade had problems and it's in an unavailable state. Whatever it is, ACE will allow you to still communicate with those downstream clusters just to make sure that everything is okay. Another reason you might use this is if you have a globally distributed cluster, right? So for example, if you live on the west coast of the United States, Rancher is in the east coast, and you have downstream clusters in the office beside you being managed by that Rancher, it's probably a lot quicker to go directly to that downstream cluster than it is to go all the way to the east coast and then back to the west, right? So that's another way to just reduce some latency, especially if you have any workloads that are using these kube configs, maybe a service account, that are doing GitHub actions, you know, automated updates, anything like that. If you actually have it talking directly to that downstream cluster, that can improve some performance there. So it's definitely not necessary, but it is very helpful, especially in that first case where you have problems with Rancher, you can still make sure your downstream clusters are in good health.
All right, and this is our 7th check. This actually composes multiple of the top 10 checks, which is why they're all together. Ensure that Rancher monitoring, Rancher logging, new vector, Longhorn, Rancher Istio, Rancher CSI benchmark, and the Rancher and Kubernetes version combination is supported. We saw this in over half of the clusters we scanned. What this check is checking for is that after you upgraded Rancher and Kubernetes, you also checked that Rancher monitoring got upgraded so that it's fully supported. It's checking that you actually have upgraded Rancher logging. One of the main benefits of this is that you don't run into issues where you raise a ticket with support and support says, well, the version of Rancher monitoring you're running is only supported up to Rancher 2.6 and you're already on Rancher 2.9. You need to upgrade monitoring before we can talk to you about anything. It also helps prevent issues where you're being exposed to CVEs or you're behind patches or you're missing features that you read about when you're looking at the docs. You're like, oh, I really want to implement this feature. Well, that's only available in monitoring version 104.2 and you're still running 101.3. So please keep up to date on everything. And again, I get that a lot of those monitoring tools, logging, things like that just work and sit quietly in the background aren't usually what we're worried about after we do a Kubernetes or a Rancher upgrade. So they frequently slip through the cracks, as we see here with 51% of the clusters having at least one of these tools missing.
Yeah. And just something else smaller to bring up. There is the rare case where people are very excited about these applications and actually upgrade them faster than they upgrade Rancher. This can rarely actually cause some problems. Say, for example, one of those applications actually has a new feature that tries to implement an API that's only available in a bleeding edge Kubernetes version that you don't happen to be running. That can cause some problems where you actually lose some functionality there instead of gaining them. So another thing to be aware of. As always, read the docs and you'll figure out if these things are actually going to happen or not.
All right, and so now we're going to talk about what's next in the pipeline. And it's something I'm actually excited about. Tyler's going to go to a live demo for it. We have created a Rancher extension so that instead of having to send you to create all your review bundles and everything all by yourself, you can now just install the charts in Rancher and then click a couple buttons that we'll walk through with you right now together.
Yeah, so to add some context to that, as it stands now, you actually have to run a command line tool. You need to have Docker installed. You need to do things like that, or at least a container management platform installed to be able to spin something up locally that then talks to Rancher and then talks to all of your downstream clusters. With this tool, it gets rid of some of that headache. You can do everything in the UI, and it's a lot easier this way. So we'll walk you through this process.
Yeah.
So once you hit get started, all you need to do is enter a bundle name, a description if you want, the namespace you want things to run in. You can add things like tolerations. So maybe an example where tolerations or a change of namespace is needed is if you have any security tools within your cluster that might disallow communication between some namespaces, or might really lock down any unknown namespace, right? So if you have a tool in there that says, you can't run as root, you can't, do anything, malicious, then it could interfere here. And for tolerations as well, if you have any taints on the nodes that would prevent us from actually running and checking certain nodes, you can add those in there to actually make sure we do get a full holistic view of the cluster.
Yeah. And then really quick, we have this nice little check mark now. So you can pull just the information for the local cluster, or you can have it automatically go down and collect information from all the downstream clusters.
Yeah. So once you hit that, it'll go ahead and start doing everything. So we'll go up to my local cluster here and we'll see what it's doing.
Yeah, so you should see 2 pods get, one job with 2 pods just got kicked off.
Yeah, so you can see there's this pod down here.
Yeah. Yeah.
There we go.
So it's running the collector container, which is what's actually doing all the collection. If it was going to every downstream cluster, this is what would be spinning up those connections to the downstream cluster, collecting all the data, compiling it in a tarball, and then once that's done, it sends it to the analyzer container, which will analyze it and generate a nice little temporary report for you in the Rancher UI.
Yeah, so to expand on that a little bit, that full report we went through is something that you get once it's sent to us. We can analyze all of the data in there and provide that additional kind of value add there. Whereas this tool here does give you that preview and kind of an overview of what we find, but it doesn't give you that full executive summary.
Which will show you a preview of what you actually can see right now. So Tyler, go click the 3 dots.
There we go.
And hit view report. There you go.
Oh no, I'm not logged in. I think that's what it is. Let's try again.
If this doesn't work, we have images from one that did work. All right, there we go. Perfect.
Go.
So it'll give you a quick overview. It will only give you the local cluster in this little preview pane. But what it'll give you is it'll give you an overall score. Again, pretty numbers that people like to see. Overall pass checks, overall failed checks, warning checks, and then on each of these tabs, it'll have little cards that will list the top 5 failures, and if you have less than 5 failures, it will list whatever failures you have and then whatever warnings you have.
Yep. And so same thing, you see that for those 4 categories that we discussed earlier.
Which cards are the most important are determined internally. We mark them as high, medium, or low. So if you have lots of different failures, we will show you the top 5 high failures before we show you any medium or low. And again, it's just a little preview here. It gives you what the failure is and an overall score, but for that individualized report breakdown, you need to download the tarball and then send it to us, which is actually really easy to do. So if Tyler goes back to review bundles and clicks on the 3 dots, there's an option to download the bundle. Once you download that, it just downloads the tarball. You can upload that to a case in SCC. Say, hi, I'd like a supportability review. Here's my bundle. And we go, great. We'll get started on that for you.
Yeah, so I think a good takeaway from this is obviously there's a lot of things out there that you may not know that because we have this collective knowledge, we've been able to compile over time. We write checks for them and they can be automatically checked for with this tool. But the best thing is that you can present this to whoever has the power to actually get things done. So be it the DevOps engineer that's actually going through and making these changes, be it a manager, director, whoever higher up actually makes those decisions. Maybe you need more budgeting. You need examples. Look at everything that they've found, right? We pay for support. They're here to help us. They want to help us through these things, but we don't actually have the manpower, for example. This is a good thing to show and give a very high-level overview. Again, pretty colors, nice diagrams, that's easily digestible and can help get those decisions made. So definitely good for that. And in the end of it, we can have a conversation about all of these things, all of the issues that you are seeing within your cluster, and find the best path forward on, what's the most important here. And what you need to fix, right? So it's a nice way to actually get introduced to support and get introduced to your environment a little bit more, learn some things you didn't know.
Yeah, this isn't like an end-all be-all, oh, I passed all the checks, everything's perfect. This is more of you're getting a wellness check at your doctor. Cool, we're just gonna review everything, make certain everything is still working well for you, make certain everything is going as well as you think it is. So that way, when things start burning, we're not surprised, we're not completely caught off guard. We at least know there are good systems in place to start with.
Yeah.
Can you go to the last slide? There we go. So yeah, if you want to get a supportability review, just open a ticket in SCC. We'll be happy to help out with that. Right now, while the UI extension is still in tech preview, it hasn't been formally released. It is a command line thing, and we will help you run the script if you hit errors, anything like that. We've seen a lot of different environments. We've helped run bundles on a lot of different customers who have hit interesting issues. Yeah, all you need to do is open up a ticket. One of our support engineers will pick it up, and we'll go through the report with you.
Yeah.
Any questions?
And as always, this is available to all Rancher Prime customers. So if you are one already, it's great. If not, you can always become one and get this as well. So questions? Yeah?
So that bundle that gets created, does it also include stuff that the regular support bundle also includes?
No. So the support bundle, when you raise a case and you ask, we ask you for a support bundle, that's going to include logs and that sort of information. This is specifically pulling metrics that then we can run through a bash script that we've written that says yes, no.
Yeah, so there might be a very small amount of overlap. So in a log bundle, we might get information about, you know, CPU and memory and things like that, but it's presented in a different format that's easily digestible by the scripts that we actually have to present that report.
Yeah.
So, your question there?
Great presentation. One question, especially as you mentioned, these version mismatch problems.
Yes.
These are probably things which we need to monitor more continuously when doing like a one-off health check. Have you looked as well into integrating these metrics or these supportability into being something which runs more automatically in the background and just gives you hey, I noticed there's a version mismatch, you probably should look into that.
So maybe to kind of point something out for that. So for applications specifically, if you do look in the Rancher UI, you go to the apps page, and you look at all the apps that you have installed, it will actually tell you if there is a new version that you have available. So there is something similar to that that can give you a little bit of an idea. It might not, you know, pop up a banner or anything like that to make it very explicit, but there is a little bit of
Also, I will say, I know as we're working on the UI tool, we're most likely going to add in automated supportability review. So it just runs once a quarter and sends the bundle to us, and it starts a proactive support ticket so we can review it and get in contact with you. Kind of like I said, it's like going to the doctor for a checkup. Depending on what your needs are, you can run it as often as you want, or you can run it as rarely as you want. I know a lot of the customers who have gotten supportability reviews have made it part of their quarterly goals to do one at least once a quarter, if not every other quarter, just to make certain that everything still looks good.
Is there potential to put in like the rancher monitoring, kind of dashboard in the future?
I don't know if there's plans to integrate with you know, monitoring or observability to have that in there. I feel like you start getting into a little bit too much of an overlap there on, you know, do you need to know if you have CPU or memory issues from this tool as well as from your observability? You know, there's already some stuff built in there. It might not be flashing at you that it's happening, but there is some overlap there. But it is definitely something that for some of these checks we can look into, right? And as always, this tool's constantly being developed, new checks added. So if you have things out there that you think of that should be added, that, you know, oh, I'm surprised it might not have, you know, caught this weird thing, we can certainly add those checks in as well. All right, no more questions. Thank you for coming.